Hi, I'm Robert Hernandez. I'm a graduate student in the Hydrogeology Lab at San Diego State University. We study a large range of topics, and I'm here to talk to you today about injection-induced seismicity. Production of oil and gas. We produce from these reservoirs not only oil and gas, but also a bunch of water. In fact, for every 1 barrel of oil we produce 12 barrels of water. What do we do with all this water? Well, the Environmental Protection Agency, the EPA, has determined that this water is far too hazardous to be put back into any drinking water supplies. It has way too many chemicals and it's far too salty. So, what it's done is it's all loaded onto a bunch of trucks and brought to an injection site. At these injection sites, there are wells that are dug deep enough so that when the water is poured back in, it's far below any drinking water supplies. In fact, over the past 7 years, more than 24 billion barrels of water have been pumped back into the ground for disposal. Now let's take a closer look at one of these injection reservoirs themselves. When water is injected into an injection well, then it increases the fluid pressure within that injection reservoir. These small fluid pressure changes radiate outwards from that point of injection. But they're contained within the reservoir and are generally safe. In fact, tens of thousands of these injection wells across the United States have operated safely for decades and are still operating safely to this day. So what happens if this injection reservoir is connected to a fault? Well, the fluid pressure increases still radiate outwards from that point of injection. But when they intersect that fault, it raises the fluid pressure within the fault itself. Let's take a closer look at a fault. There are two main stresses that act on a fault. The first one promotes fault slip, and it's called shear stress. The second one serves to counteract this shear stress and clamp the fault together, and it's called normal stress. When the fluid pressure increases of an injection well intersect a fault, it raises the fluid pressure within that fault itself. These fluid pressure increases reduce the normal stress, effectively unclamping that fault. If that unclamping is great enough, then the fault will slip, and fault slip causes earthquakes. Here in the Hydrogeology Lab at San Diego State, we build physical models of injection wells and faults just like this, with the goal of better understanding how this injection-induced seismicity occurs, and hopefully in the future learning how to mitigate it.